demonstrates how to set important custom defaults within SIMATIC Manager. To begin, select the Options menu in SIMATIC Manager. Then select Customize. Then the Language tab. In the National Language box, you can choose from the installed languages to set the menu display language. In the Mnemonics box, if mnemonics are set to English, code mnemonics such as inputs will display with I and outputs with Q. If the mnemonics are set to German, code mnemonics such as inputs will display with the E for Eingang and outputs with A for Ausgang. Click the Help button on any tab for more detailed help. Select the General tab. Set the default storage locations for your projects and the storage location for libraries here. If you put a check in the box Open New Object automatically, when you create an object such as code block, the programming editor will open automatically. Now, select the Date and Time of Day tab. Here, you can set the date and time format. Placing a check in the box Display Module Times and Local Time of the PGPC will convert diagnostic message timestamps to the local computer's time. This box should only be checked if the PLC is set to Universal Time, or UTC. Now, let's select the View tab. Here, you can change the background color and text color for online windows. Display Operating Mode in Module Symbol is checked by default. This shows the operating state of the CPU, for instance, run or stop in online windows. Always Read Data from CPU on Opening Blocks folder is also checked by default. When you open an online blocks folder, this option tells SIMATIC Manager to get the block list from the online PLC. By default, Enable Access Address to be modified is not checked. Online window access addresses are displayed in the Windows Object Properties and obtained from SIMATIC Manager. It is strongly recommended that you not select this option. Display Quick View during the hardware diagnostics is checked by default. This shows only the PLC and module faults with brief information when hardware diagnostics is launched from the diagnostics setting choice of the PLC menu. Unchecking this box will give more detailed information in the hardware diagnostics window, but takes longer to load the information. Open New Window automatically on changing view is checked by default. This opens an online view in its own window. Select the Columns tab. The Visible Columns box contains columns that show when the blocks folder is viewed in detailed view. Select the Message Numbers tab. This is where you choose whether alarm messages will be tied to the CPU or the project. HMI programs Pro Tools version 6 or WinCC Flexible version 6 or later support CPU-oriented messages, and this is the default. Select the Archiving tab. When archiving a project, by default, you are prompted to choose if you want to span across multiple disks. Since floppy disks are seldom used anymore, uncheck the Check Options box to disable this prompt. This concludes the video for SIMATIC Manager Customized Defaults. This video shows how to transfer Siemens software licenses with Automation License Manager. First, open Automation License Manager. In the tree at the left side of the window, the available disk drives are shown. In this example, there are a number of licenses on the C drive. Select one or more to transfer. Select the License Key menu. Then choose Transfer. Click the drop-down button to browse to the target drive. In this example, we will transfer the license to a removable drive. Click OK. Let's take a look at the target drive. Here is the license that we transferred. Transferring licenses from a removable drive works the same way. Select one or more licenses to be transferred. Select the License Key menu again and choose Transfer. Browse to the target drive. We will send this license back to the C drive. Click OK. Highlight the C drive. The first license is the one that was transferred from the removable drive back to the C drive. To transfer all licenses, select a single license, press and hold the Control key plus the A key to select all. Click the License menu. Choose Transfer. Select the target drive and choose OK. All licenses will then be transferred to that drive. This concludes the video on transferring licenses with Automation License Manager.
Here you'll see how to find installed Siemens software and version information. This is shown using Windows 7. Click the Start button on your desktop. Click Siemens Automation. Click SIMATIC. Then click Information. Click Installed Software. Resize the windows to make the viewing area larger. Here you can see the software package installed, the version, release, and release number. Click the Components tab. Here you see components of the installed software. Click the Hardware Updates tab. If any updates have been installed, you will see them here. Click the System Files tab. On this final tab, you'll see the list of the SIMATIC system files that's in use by the system. Here you'll see how to find installed Siemens software and version information. This is shown using Windows 7. Click the Start button on your desktop. Click All Programs. Click Siemens Automation. Click SIMATIC. Then click Information. Click Installed Software. Resize the windows to make the viewing area larger. Here you can see the software package installed, the version, release, and release number. Click the Components tab. Here you see components of the installed software. Click the Hardware Updates tab. If any updates have been installed, you will see them here. Click the System Files tab. On this final tab, you'll see the list of the SIMATIC system files that's in use by the system. In this video, you'll learn how to create a project using Step 7 Classic. On your desktop, double-click SIMATIC Manager. There are two ways to create a new project. Click Click File and New to get a basic empty project container with stations and details to be added later. Click New Project Wizard if you know your CPU and you'd like a hardware station and program folder. We'll create the first project by selecting File and New. The New Project window opens. Give your project a name, such as my_project. Next to storage location, click the Browse button if you'd like to change the path. Choose the folder to store your project in, and click OK. Click OK again. You now have a basic empty container project that's ready for a hardware station and program code to be added. We'll now build a second project using the New Project Wizard. Click the File menu and select New Project Wizard. Click the Preview button to show the project structure as you're building it. Then click Next. Scroll down the CPU list until you find your CPU and click to select it. Drop down the MPI list if you'd like to change the CPU's MPI address. We'll select address 5. Then click Next. Scroll down the blocks column and add any organization blocks that you want to your project. We'll add OB35. However, you can also do this later after the project's been created. Select the programming language. You can easily change this in the program later. Click Next. Select the project name box and name your project. Click Finish to complete the wizard. You now have a beginning project with the hardware station, the CPU, program folder, and the blocks OB1 and OB35 in it. This video will help you determine how large an open S7 project is, an S7 zip project size, and the size of the blocks folder which gets downloaded to the PLC. Let's first determine the size of the blocks folder which gets downloaded to the PLC. Right-click on the blocks folder. Choose Object Properties and click on the Blocks tab. 7,898 bytes of load memory gets downloaded to the micro memory card, or MMC. The load memory is part of the user program and is the non-volatile RAM. Work memory is the high-speed memory of the PLC, which contains only the executable information and is a subset of the load memory. In this case, the work memory is 5,478 bytes. The system data memory, 23,862 bytes, is the hardware configuration data and also gets downloaded to the micro memory card. So how much room will this project take on the micro memory card? The user program load memory, 7,898 bytes, plus the system data memory, 23,862 bytes, equals 31,768 bytes, or approximately 32 kilobytes. The micro memory card should be at least 60% larger than this to have working room. A minimum 1 megabyte card would be needed. If you plan to store other documents or the archived project, the card will need to be considerably larger. Let's now find the size of our open project. The project is stored on the D drive in the Courses folder with the name my_proje. Open Windows Explorer. We will select the D drive, the Courses folder, right-click on my_proje, and select Properties. The disk storage space of the open project is 20.1 megabytes. Click the OK button. Now let's check the size of the archive project. To see how to archive a project, you can watch the video on archiving a Step 7 project. An archive of my_project has been stored in the archives folder and named S7_zipped_project. The archive size is approximately 4.4 megabytes. Most of the size comes from the HMI panel. If we wanted to place an archive of this project on the micro memory card, we would have to remove the HMI station first. The project archive right above this one has had the HMI removed and is only 674 kilobytes. In this video, you have seen how to find the size of the blocks folder, which gets downloaded to the micro memory card in the PLC. You have also seen how to find the open project size and the archived project size. And that concludes this video. This video will help you determine how large an open S7 project is, an S7 zip project size, and the size of the blocks folder which gets downloaded to the PLC. Let's first determine the size of the blocks folder which gets downloaded to the PLC. Right-click on the blocks folder. Choose Object Properties and click on the Blocks tab. 7,898 bytes of load memory gets downloaded to the micro memory card, or MMC. The load memory is part of the user program and is the non-volatile RAM. Work memory is the high-speed memory of the PLC, which contains only the executable information and is a subset of the load memory. In this case, the work memory is 5,478 bytes. The system data memory, 23,862 bytes, is the hardware configuration data and also gets downloaded to the micro memory card. So how much room will this project take on the micro memory card? The user program load memory, 7,898 bytes, plus the system data memory, 23,862 bytes, equals 31,768 bytes, or approximately 32 kilobytes. The micro memory card should be at least 60% larger than this to have working room. A minimum 1 megabyte card would be needed. If you plan to store other documents or the archived project, the card will need to be considerably larger. Let's now find the size of our open project. The project is stored on the D drive in the Courses folder with the name my_proje. Open Windows Explorer. We will select the D drive, the Courses folder, right-click on my_proje, and select Properties. The disk storage space of the open project is 20.1 megabytes. Click the OK button. Now let's check the size of the archive project. To see how to archive a project, you can watch the video on archiving a Step 7 project. An archive of my_project has been stored in the archives folder and named S7_zipped_project. The archive size is approximately 4.4 megabytes. Most of the size comes from the HMI panel. If we wanted to place an archive of this project on the micro memory card, we would have to remove the HMI station first. The project archive right above this one has had the HMI removed and is only 674 kilobytes. In this video, you have seen how to find the size of the blocks folder, which gets downloaded to the micro memory card in the PLC. You have also seen how to find the open project size and the archived project size. And that concludes this video. In this video, you'll see how to archive an S7 project. In order to archive an S7 project, all editors which access the project must be closed. Select the File menu. Choose Archive. The path will default to the open project. If there's no project open, you'll have to browse to the one you want to archive. Select the folder you want to store the archive in, and click Save. If you see the message Archive on multiple data media, the default is No. Click OK. And the project archives. If you would like to turn the option to archive on multiple data media off, click the Options menu of SIMATIC Manager. Choose Customize. Click the Archiving tab and deselect the Check Options box. Click OK. Let's archive again by choosing File, Archive. The open project is the default. Click OK. Choose the storage location and click Save. This time the project archives with no pop-ups. And that concludes this video. You'll see how to retrieve a project and what to do if you retrieve more than one of the same project. Select the File menu. Choose Retrieve. Navigate to the folder your archive is stored in and double-click to retrieve. Choose the folder you want to retrieve the archive to and click OK. And the archive unzips. You'll get a message telling you that the data has been retrieved and what directory it has been stored in. You can check this box not to have this message display in the future if you like. Click OK. Click Yes to open the project. Now let's retrieve the same project again. Click the File menu. Choose Retrieve and double-click the file. Select an archive location and choose OK. And the file unzips. This time you don't see the message telling you that the file was retrieved since we clicked not to show it again. Click Yes to open the project. Here you can see that an _1 was addended to the new project retrievals path, but the project name is exactly the same. This could become very confusing if you retrieve a project more than once. It is recommended that you change the project name itself to help keep them straight. Let's add the word backup to this one. Now it's easier to tell the projects apart, and that concludes this video. You'll see how to use Save As to save a copy of a project and possibly fix a project with internal errors. To save a copy of the working project, first close all editors such as the programming editor, the hardware configuration editor, and so forth. Then click the File menu. Choose Save As. If you have seen the uncommon message saying that your project has internal errors, place a check mark next to the reorganization with slow in parentheses. This is a much slower form of Save As, but reorganizes the database and will often fix a project that has internal errors. If you have done this once and you still see a message stating that the project has internal errors, repeat the process again. Sometimes a second reorganization of the database will fix a project if there were a large number of errors. Select the name box and choose a new name for this copy. We will name this one my_new_project and click OK. SIMATIC Manager will begin making a new copy. If with reorganization was checked, it may take several minutes. When the process is complete, your new project copy opens, and that concludes the video on saving a Step 7 project with Save As. This video, you'll see how to save an S7 project to the micro memory card of the PLC. The S7 micro memory card is in the PLC. Highlight the S7 300 CPU or below in the project tree. Select the PLC menu. Choose Save to Memory Card. This project does not have an HMI station. If it did have an HMI station, the project would be too large to store on the micro memory card. If you need help finding the blocks folder project size, see the video, How Big is My Project? By default, two boxes are checked. The first one, Current User Program, and in parentheses, including hardware configuration, has the caution on the right side that says the memory card will be completely deleted if Current User Program is selected. What this does is erases the micro memory card and re-downloads all the blocks folder data, plus puts an archive of the current project on the micro memory card. This will require a CPU stop. We will uncheck this option. It is also possible to transfer files and documents using the lower part of this window, and this is demonstrated in the video, Save Files and Documents to the MMC. Now only an archive of the current project will be added to the micro memory card. Click OK. SIMATIC Manager archives the project and transfers it to the S7 micro memory card. The Download Files to EEPROM memory card on the CPU window opens. During the transfer time, this window appears to be non-responsive, but be patient. After several minutes, the file may appear to transfer all at once. Let's go check the micro memory card. Click the Accessible Nodes button. Drop down to the Blocks folder. The archive is stored in a folder called Your Project Files. Highlight the folder Your Project Files in the left window to see the archive project in your right window. And that concludes this video. Shows how to save an S7 project to the MMC offline using a Siemens PG. Pictured is a Siemens M3 PG. The micro memory card reader is on the right side when the PG screen is facing you. The micro memory card goes in with the prongs facing up. Do not attempt to work with an S7 micro memory card in an SD card reader, or you'll ruin the card and it can only be fixed by returning it to the factory. Also, if you are working with a different model Siemens PG, consult the manual to make sure you know which slot is the one for the S7 micro memory card. Some PGs may have both an SD card reader and a micro memory card reader. The card has been inserted into the Siemens PG micro memory card reader. Select the File menu. Choose S7 memory card and open. When the S7 memory card window opens, the S7 memory card folder will automatically be selected. This micro memory card is empty. With the S7 memory card folder selected, click the PLC menu. Choose Save to Memory Card. To place an archived copy of a project or library on the MMC, click the Project/Libraries button. Navigate to the project whose archive you want to store. In this example, we will store the project named My_project. Click OK to select the project, and click OK again. SIMATIC Manager creates an archive. The project archive is transferred to the MMC. The Save Files on Memory Card window may appear to be inactive for several minutes, but be patient. The file may appear to finish transferring all at once. You'll be notified when the transfer is complete. Click the Close button. Drop down the S7 micro memory card and select your project files in the left window. You will see the archive project in the right window. And that concludes this video.
video demonstrates how to save documents and other files to a micro memory card in the PLC. Highlight the Blocks folder in your project. Select the PLC menu. Choose Save to Memory Card. This demonstration focuses on saving documents and files to a memory card, so deselect Current User Program. Also, deselect Current Project. Navigate to the file you want to transfer. We will transfer 2 files from Libraries and Documents folder. Highlight the file you want to transfer. In this example, it will be a spreadsheet named S7 Module Order Numbers. Click the arrow to add the file to the download list. The next file will be an exported symbol table named Symbol Table. Highlight the file and click the Add arrow. Be careful about adding too many files or large files overloading the micro memory card. Click OK to transfer the files to the MMC. A Transfer Finished log shows the size of the file transfer. In this example, it was 32 kilobytes. To view where the files are stored on the MMC, click the Accessible Nodes button. Fully expand the project tree. Click on Your Project Files. Here is the S7 Module Order Number spreadsheet and the symbol table. The My Project file was added at a different time. To see how to transfer a zipped copy of your project to the micro memory card, as well as important cautions, see the videos on transferring a project to the MMC in the PLC and transferring a project to the MMC using a Siemens PG. How to retrieve a project from and how to retrieve files and documents from the micro memory card is also shown in separate videos.
In this video, you'll learn how to clear a micro memory card and perform a memory reset of the CPU using SIMATIC Manager. To clear the micro memory card, you'll need an online view, so select the Blocks folder. Click the Online button. Select a block in the online view. Hold down the Control key plus the A key. This selects all the blocks plus the System Data folder, which contains the hardware configuration. Right-click in the highlighted area and select Delete. Click Yes to the warning message. System functions, or SFCs, and system function blocks, or SFBs, are burned into the CPU's EEPROM, and this warning tells you they cannot be deleted. The user blocks, though, still will be deleted, so click Yes. All user blocks have been deleted, and even though the system data folder is still there, it has been emptied and the hardware configuration also deleted. The micro memory card is now clear. Now let's memory reset the CPU and clear any RAM that may be in use. Click the PLC menu. Click Diagnostic Setting from the context menu. Click on Clear Reset. Click Yes to the Clear Reset warning. This will also put the CPU in the stop mode. The micro memory card and CPU's RAM have both been cleared. If you would like to restart the CPU, you can do this from SIMATIC Manager. Go to the PLC menu. Click Diagnostic Setting again. This time select Operating Mode. Click the Warm Restart button. This concludes the video on how to reset the micro memory card and the CPU. In this video, you'll learn how to clear a micro memory card and perform a memory reset of the CPU using SIMATIC Manager. To clear the micro memory card, you'll need an online view, so select the Blocks folder. Click the Online button. Select a block in the online view. Hold down the Control key plus the A key. This selects all the blocks plus the System Data folder, which contains the hardware configuration. Right-click in the highlighted area and select Delete. Click Yes to the warning message. System functions, or SFCs, and system function blocks, or SFBs, are burned into the CPU's EEPROM, and this warning tells you they cannot be deleted. The user blocks, though, still will be deleted, so click Yes. All user blocks have been deleted, and even though the system data folder is still there, it has been emptied and the hardware configuration also deleted. The micro memory card is now clear. Now let's memory reset the CPU and clear any RAM that may be in use. Click the PLC menu. Click Diagnostic Setting from the context menu. Click on Clear Reset. Click Yes to the Clear Reset warning. This will also put the CPU in the stop mode. The micro memory card and CPU's RAM have both been cleared. If you would like to restart the CPU, you can do this from SIMATIC Manager. Go to the PLC menu. Click Diagnostic Setting again. This time select Operating Mode. Click the Warm Restart button. This concludes the video on how to reset the micro memory card and the CPU. In this video, you'll see how to clear a micro memory card offline using a Siemens PG. Pictured is a Siemens M3 PG. The micro memory card reader is on the right side when the PG screen is facing you. The micro memory card goes in with the prongs facing up. Do not attempt to work with an S7 micro memory card in an SD card reader, or you'll ruin the card and it can only be fixed by returning it to the factory. Also, if you are working with a different model Siemens PG, consult the manual to make sure you know which slot is the one for the S7 micro memory card. Some PGs may have both an SD card reader and a micro memory card reader. The micro memory card is inserted in the PG. Select the File menu. Choose S7 memory card. Selecting Delete here will clear the S7 micro memory card. If, however, you want to see what's on the card, go to the File menu, choose S7 memory card again, and choose Open. The contents of the card will now be displayed. You can also delete the card here by right-clicking on the S7 memory card and choosing Delete from the context-sensitive menu. Click Yes to confirm that you want to delete the card, and the micro memory card has now been cleared. This concludes the video on how to clear an S7 micro memory card offline using a Siemens programmer or PG.
In this video, you will see how to compare an online project in the PLC to an offline project in SIMATIC Manager. The programming editor must be closed to perform a block comparison. To begin, be careful to highlight the blocks folder. If a single block is highlighted, only that block will be compared. Select the Options menu and choose Compare Blocks. You can also right-click on the Blocks folder and choose Compare Blocks. You have the option to include system data blocks, which would be the hardware configuration, to compare only to see if the timestamps are the same, or the default, which is to execute a code comparison of the blocks. We're going to execute a code comparison. Click Compare. SIMATIC Manager then runs a block-by-block comparison. Data blocks will almost always show in the comparison because the actual values are changing. To omit the data blocks, place a check in the box Hide data blocks with different actual values. Path 1 is the offline project storage location. Path 2 is the online PLC program. In the comparison list, OB100 says that Path 1, the offline project, contains a newer version. Highlight the OB100 block. If you would like to see a description of differences, click the Details button. The Details window shows timestamps, interface changes, size, length changes, and so forth. Click the Close button. Make sure that OB100 is highlighted and click the Go To button. This opens a detailed side-by-side view of the blocks. The offline block is on the left and the online block is on the right. If you look in the Comparison tab at the bottom of the program editor, it tells you that in Network 1 of this statement list code, the offline block contains the command less than or equal to as integers, while the online block contains the command equals, which means equals to as integers. The second line in the Comparison tab says that Network 2 of the offline block contains the command greater than or equal to as integers, while the online block contains the command equals as integers. We would now decide which block is correct and sync the two with the download if the offline block is correct, or close the offline block and perform a save to transfer the online block to the blocks folder. Close the programming editor. In the comparison list, FC3 is also newer in the offline version. Highlight FC3 and click the Details button if you want to see a description of the changes. Here you can see that the offline block size is smaller than the online block size. Close the Details window. Click the Go To button. In the Comparison tab at the bottom of the programming editor, Network 3 in the offline block shows an operator of greater than or equal to 1. This means the network is using OR logic. Network 3 of the online block has newly added AND logic, which is the open contact input 0.4. We would now decide which block is correct. If the offline block is correct, we would download it to the PLC. If the online block is correct, we would close the offline block and perform a save. Close the programming editor. F16 in the comparison list shows that Path 2, the online path, has the newer version. Click the Go To button. In the Comparison tab at the bottom of the programming editor, you can see that Network 4 in the online window has the added address M87.5. Close the programming editor and close the Compare Blocks results window. You have the ability to do a Path 1, Path 2 comparison. This is shown in the video Compare to S7 Offline Projects. Close the Compare Blocks tool. This concludes the video Compare S7 Online Project to Offline Project. In this video, you will see how to compare to offline Step 7 projects. To begin, right-click the Blocks folder, choose Compare Blocks, and select Path 1, Path 2. The open project will be Path 1. Next to Path 2, click the Select button. Click the drop-down in the Project Name field and navigate to the project where you want to compare. We will select My_Backup_Project. Navigate down to the Blocks folder of the project. With the Blocks folder selected, click OK. We will choose to perform a code comparison. Click the Compare button. The first block, OB100, shows that Path 1 has a newer version. However, in the Notes field, the interface and block code are identical. Only the timestamps are different. This means that Path 1 was saved after Path 2. Perhaps a change was made and then reversed. Also notice the Go To button is grayed out because there's no difference in the code. The icon next to the result shows a yellow box over a green square. The yellow box indicates a timestamp difference and the green square means the code is the same. You can click the Help button to see more icons and their meanings. Click the Details button to see a description of the differences. The block in Path 1 shows a much newer timestamp than Path 2, but everything else is the same. Close the Compare Blocks Details window. The icon next to the FC3 block is a yellow box on a red square. The yellow box means there's a timestamp difference, and the red square means there's also a code difference. Select the FC3 block. The Note window confirms that the code blocks are different. Click the Details tab only if you wish to see a description of the differences. The Path 2 block is larger. Click the Close button. Click Go To. The Comparison tab at the bottom of the programming editor shows that in Network 1 of Path 1, the timer is an extended pulse timer, whereas the timer in Network 1 of Path 2 is an off delay timer. The second statement in the comparison window shows that network 2 of path 1 is identical to network 3 of path 2. This means a new network 2 has been added to the path 2 project. Close the compare blocks results window and close the compare blocks window. This concludes the video on comparing two S7 offline projects. This video demonstrates how to upload a station from the PLC. It is recommended that you create a new project for the uploaded station. Uploading a station to an existing project could cause a duplication of networks and addresses. Click the File menu, select New, and give the project a name. We will name this one Upload Project. Click OK. With the project level highlighted, select the PLC menu. Choose Upload Station to PG. Choose Slot 2 for the PLC. Click View to poll the accessible nodes. The CPU is selected. Click OK. The station begins uploading. Drop down to the Blocks folder. Reposition the uploaded project window. If you have an offline project, you can copy the symbol table and paste it to the uploaded project. Choose Yes to overwrite the existing empty symbol table. Select the Blocks folder and let's open a block. How about FB11? You will see a message saying there are no parameter and local variable names. That's because they are not stored in the PLC. Click OK. You will see a message telling you that this block does not contain symbol information. Click OK. Select the N local variable. In this view, you can see the local variables have lost their user-assigned names. Let's close this block. Let's open another block. We'll choose FC16. Again, you will see the no parameter and local variable name message. Click OK. The no symbol message also displays. Select OK. Because we copied the symbol table over, any I/O in the symbol list will be named. You will see that the data block 99 elements do not have symbol names. Close the block. Let's open data block 99. The no parameter and local variable name message displays. Click OK. The user-defined names have been lost. While uploading a station is possible, be aware that you will not get parameter and local variable names in your blocks. Symbol names can be replaced by copying a new symbol table to the uploaded project. This concludes the video on uploading a station from the PLC.
This video shows how to use the SIMATIC Check Block Consistency tool. The Check Block Consistency tool is used to make sure that block calls and interfaces are correct. It is a great tool for updating function block data block calls and user data type or UDT calls. To begin, right-click on the Blocks folder. Select Check Block Consistency. There's a red X next to DB18 and a yellow exclamation point next to FB18. The problem resides in OB1. The FB18 DB18 call is being made in OB1, and there's also a yellow exclamation point next to FC4. Click the dependency structure icon to see only the blocks that have interface problems and what block they depend on to run. To see the meanings of the icons, press F1 for help. Click buttons in the tree view. The red X indicates that an object must be recompiled, and the yellow exclamation point indicates a timestamp conflict, which generally means there's an interface problem, such as added local variables in a block where the call to the block has not been updated. Close the help screen. Let's go back to the tree reference view. We will now compile all the blocks and see if that fixes the interfaces. Click the Compile All button. The compiler runs. The compiler indicates there's an error. OB1 could not be compiled and it still contains a timestamp conflict. The red X is gone next to DB18, but there are still yellow exclamation points next to DB18, FC4, and FB18, all being called from OB1. Close the check block consistency window. Let's open OB1. The programming editor tells us there's a timestamp conflict with at least one block call. Click OK. Scroll down the block to find that the FC4 block is red. The pop-up note tells us that the interface has changed. Right-click the block. From the context-sensitive menu, choose Update Block Call. This option only shows when there's an interface conflict of a block call. The editor shows the old block on the left side and the new block on the right side, which contains a new input variable named PV. Click OK to accept the new block. The compiler opened this block but could not fix it because a formal parameter had to be supplied to the input variable of the FC, and only the user can do that. The formal parameter should be an integer, so we will enter the integer value 55. Save the block. No other conflicts showed, so let's close the block. Right-click the blocks folder again and choose Check Block Consistency. No conflicts are showing. When OB1 was opened, the FB18-DB18 interface was automatically updated, and we fixed the call to FC4. The Check Block Consistency tool can generally fix interface issues with function blocks, data blocks, and user-defined data types or UDTs. The tool cannot fix interface changes to functions or FCs. The user must do that. This concludes the video on using the Check Block Consistency tool. In this video, you'll see how to reassign I/O in the code with the SIMATIC Rewire tool. The purpose of this tool is to replace old input and output assignments with new ones in the code. This can only be done offline. It is possible to rewire involving peripheral addresses. Consult the S7 help for the Rewire tool. To begin, be careful to select the blocks folder. Selected, only those blocks will be affected. Select the Options menu and choose Rewire. Alternatively, you can right-click on the blocks folder and choose Rewire. Under Old Address, type an I/O point that you wish to replace. We will replace the address Q8.5. Under the New Address column, type in the replacement address. The new address will be Q9.5. We will now replace Q8.6 with Q9.6. We will replace input 0.0 with input 10.0. We will replace input 0.1 with input 10.1. A special consideration here is that if you are using a project that was created in Europe and the row is still red after you have entered both a valid old address and a valid new address using I for input or Q for output, and you've clicked on a new row, then try entering an E for Eingang, which is German for input, and A for Ausgang, which is German for output. When all entries are made, click OK. After the Rewire tool has completed its function, you'll be asked if you want to open the protocol file. Choose Yes. The protocol list shows the blocks that were affected and the number of replacements made. Close the Rewire tool. Let's open FC14. Here is one of the entries that was changed. Q8.6 was changed to Q9.6. That concludes the video on reassigning I/O with the SIMATIC Rewire tool.
This video demonstrates how to copy a WinCC Flex HMI to your SIMATIC project. This is video 1 of a two-part series. This video demonstrates the HMI copy and hardware configuration setup. Part 2 shows how to configure the connections and tags. To begin, open both the project that has the HMI you want to copy and the project you want to copy the HMI into. Drag the HMI from the project level of the From project to the project level of the To project. Expand the project tree where the new HMI was added. Highlight the top level of the HMI station. Double-click Configuration. This will open the Hardware Configuration Editor for the HMI. This is where you tell the HMI how it will communicate with the PLC. If you're connecting by MPI or Profibus DP, then double-click the HMI MPI/DP row. In the Interface drop-down, choose whether you will be using the MPI or Profibus interface. In this demonstration, we will be connecting by Ethernet, so we will cancel here. Select the line that says HMI IE. The IE stands for Industrial Ethernet. In the Interface area, click the Properties button. An Ethernet subnet already exists in the project. Select it from the list. You could also create a new subnet from here, but this is usually done in the configuration of the PLC's hardware. Now click the IP address field. The IP address of this HMI is 192.168.111.101. which is a unique address on the existing Ethernet network. The address has also been physically entered into the HMI, which can be seen in the video Setting an Interface Address in the HMI. OK the interface window, and OK the Properties window. Click the Save and Compile button. This transfers all the configuration information to the WinCC Flexible project. You will see this in Part 2 of this series. Do not download here. Close the Hardware Configuration window. In Part 1 of this video series, we copied an HMI from an existing project to a new project. We went into the hardware configuration and told the HMI what network it would communicate on and gave it an address. That address was also physically entered into the HMI, which was not shown here. In Part 2 of the series, you will see how to set up connections and reconnect tags in the new project and then download it to the HMI. This video is part 2 of Copy a WinCC Flex HMI station to your SIMATIC project. Video part 1 demonstrated how to set up the HMI station hardware configuration, which needs to be done before doing these steps. There are several ways that you can open WinCC Flexible from your SIMATIC project. Here is one way. Right-click on the WinCC Runtime project level and select Open Object. If you need to change the device type, right-click on the existing device and choose Change Device Type. From the list, select the HMI device that matches your physical device and click OK. WinCC Flexible will redraw all the graphics for the new device's screen. You will need to check it, of course, and make adjustments as necessary. Now, let's set up connections. Under Communication in the HMI project tree, double-click Connections. There will probably be one or more connections from the project you copied from. WinCC Flexible will also automatically add a connection for the project you copied into. Here, Connection 4 is the new connection for this project. You can tell by looking in the Station column to see this SIMATIC Manager's project name, and the Partner column to see the CPU's name from this project, and in the Node column to see the CPU's port name from this project. Also, Connection 1 through 3 do not have any of the information because it was lost during the transfer from the last project. Let's right-click on the icon to the left of the connections 1, 2, and 3 and delete them. Make sure you set Connection 4's Active column to On. The other columns were set correctly during the integration of the HMI station to the SIMATIC Manager project. In the HMI project tree, still under Communication, double-click Tags. If the tags from the previous HMI station are not valid for the new HMI station, you can delete them. In this case, the projects are similar and the tags are valid. The orange color means there's a problem. In the Connection column, the existing connection is named Connection 1 from the previous HMI station. Our new connection is named Connection 4. Probably the easiest fix is to rename the connection. To do this, click the Connections tab at the top of the window. Select Connection 4 and rename it to Connection_1. Switch back to the Tags tab. The Connection column is fixed. The tags highlighted in orange are still connected to the other project's CPU. We're now going to connect them to this project's CPU. To do this, highlight the first orange tag. While holding down the Shift key, click on the last orange tag so they are all selected. Select the Options menu and click on Reconnect. Put a bullet next to one or more of the following connections are true. Put a check in the box Address and Data Type Match. These two checkboxes will search the existing symbol table for symbol name matches or absolute address matches, which allows the most flexible search and gives the best chance for tag matches. Click OK to begin the Reconnect search. Let's click off the highlighted fields. All tags were found and reconnected to this PLC. If there were any names still highlighted in orange, it means they were not found and we would have to delete them from this list and connect the correct ones from the project symbol table. It's a good idea at this point to rebuild the HMI project's database. For help with this, watch the video Rebuild and download the HMI project.
This video shows how to upgrade an S7-300 CPU's firmware using a micro memory card. To begin, we are going to place a CPU upgrade firmware file on a micro memory card or MMC. The first thing to note is that you will need an 8 MB or larger card. Insert the MMC into a Siemens PG. In SIMATIC Manager, open the PLC menu. Choose Update the operating system. Navigate to the firmware update file and select the file cpu_hd.upd. Then click Open. The transfer process will begin and may take several minutes. After the file is transferred to the micro memory card, you will see a success message. Click OK. Let's go observe the CPU during the update process. This is going to take about 2 minutes, and then at the end there's a recap screen with all the steps on it. With the CPU in the stop mode, remove the communication cables, turn the CPU off, and remove the project micro memory card. Replace it with the firmware memory card. Then turn the power on. All the lights will illuminate and stay on for about 16 seconds or so. I know this part isn't too exciting, but hang in there with me a little while longer. The lights go out. And then show again. The run and stop light flash together for about 16 seconds or so. Stay with me a little while longer. The stop light flashes quickly and will do this for about 18 seconds. We're getting pretty close now. Stay with me a few more seconds. When the stop light flashes slowly, the firmware update is complete. Turn the power off and remove the firmware MMC. Replace the project MMC and turn the power back on. Reconnect the communication cables and place the PLC in run when ready to run the program. The process is complete and successful. What follows is a recap of the steps that we just went through. Here's a recap of the steps to update an S7-300 CPU's firmware using an MMC. If you have a Profinet CPU, you may also be interested to watch the video on upgrading an S7-300 Profinet CPU's firmware online. This video shows how to upgrade an S7-300 CPU's firmware using a micro memory card. To begin, we are going to place a CPU upgrade firmware file on a micro memory card or MMC. The first thing to note is that you will need an 8 MB or larger card. Insert the MMC into a Siemens PG. In SIMATIC Manager, open the PLC menu. Choose Update the operating system. Navigate to the firmware update file and select the file cpu_hd.upd. Then click Open. The transfer process will begin and may take several minutes. After the file is transferred to the micro memory card, you will see a success message. Click OK. Let's go observe the CPU during the update process. This is going to take about 2 minutes, and then at the end there's a recap screen with all the steps on it. With the CPU in the stop mode, remove the communication cables, turn the CPU off, and remove the project micro memory card. Replace it with the firmware memory card. Then turn the power on. All the lights will illuminate and stay on for about 16 seconds or so. I know this part isn't too exciting, but hang in there with me a little while longer. In this video, you will see the two types of 32-bit pointers. There are two types of 32-bit pointers, area internal and area crossing. Area internal pointers have the format p-pound byte address dot bit address. Area internal pointers do not contain an area such as input, output, memory, data block, or local as part of the pointer's address. Area internal pointers are used for indirect addressing, which can use M-memory or local memory, as well as the address registers AR1 and AR2. 32-bit area crossing pointers have the format p-pound, area, byte address, dot bit address, and do contain the area as part of the pointer's address. Area crossing pointers are used for register indirect addressing with AR1 and AR2. The p-pound causes the ones and zeros to be formatted such that bits 0 through 2 correspond to the bit address and bits 3 through 18 correspond to the byte address, which is stored as an unsigned integer. Bits 0 to 2 have the weighted values 1, 2, and 4. The minimum value can be 0 and the maximum value 7, which corresponds to the bits of a byte. The weighted values start over for bits 3 through 18, which contain the byte part of the address. The byte address range is from 0 to 2 to the 15th power. If bit 31 of the double word is 0, the pointer is area internal, and if it is 1, it is an area crossing pointer. For example, consider the area internal address p-pound 8.3. The bits would be stored in the fashion shown. Bit 0 to 2 would contain 110, making up the decimal value 3. There would be a 1 in bit 6 with weighted value 8, making up the byte part of the address. This bit pattern would be the area internal address p-pound 8.3. This address could be stored in a memory double word, local variable double word, or in address registers 1 or 2. The 32-bit area crossing pointer is similar to the area internal, except the area is stored as part of the address. Consider the example p-pound M27.0. The bit part of the address would contain all zeros. The byte part of the address would have a 1 in bits 7, 6, 4, and 3, whose weighted values sum to 27. The area part of the address is stored in bits 24, 25, and 26. If the bit pattern is 000, the area is peripheral input or output. If the bit pattern is 001, the area is input. If the bit pattern is 010, the area is output. 011 is bit memory, as in the example here. 100 is the data block area in DB register 1, which is a global DB. 101 is the data block area in DB register 2, which typically is a data instance block, but can be global DB if the programmer has intentionally loaded a global DB in DB register 2. 110 is local data in the interface area of a block. 111 is the local data area of a calling block. Bit 31 will be 1, which means area crossing pointer. You can see examples of area internal and area crossing pointers used in the code by watching the memory indirect addressing and register indirect addressing videos. This concludes the video on 32-bit pointers.